Hello, my name is Joseph Shaheen, and in this video, I'm going to explain my code and algorithm behind the simple Ring doorbell change detection camera. So to start off, I'm not using my webcam just because I don't have a webcam and I have nowhere to set my computer up properly. So instead, I'm going to be using a video that I recorded in front of a locker and then someone walking up to that locker. All right, so just to get that out of the way. Over here, I have a starter function. This is the mask function. So it masks out the part of the area that I care about, which is right in front of the locker. Here, right in front of the locker. So here are just like the points, and then I create a polygon with those points, and then I just mask it. The next function is the process function. It takes in two images. It masks both images. It converts the masked images to a grayscale. And then I blur both of them using a kernel size of 51. That's just what worked for me. I was getting a lot of noise otherwise, so yeah, 51 really worked. Got rid of a lot more noise. I had it before. Anyways, the next part is the difference. So I take the absolute value of the difference between the first frame and the second frame. So I take frame 2, which is blurred 2, minus blurred 1, which is effectively what this does. And then I take the absolute value of that. So for example, if a pixel had a value of 255, and remember it's a grayscale, so it's only one value, and then the second pixel from the other picture had a value of 100, then the difference between those would be 155. And that's what would be the pixel value of the differenced image. Because I still had a lot of noise, I did a second blur over the image, which contained a difference in pixel values. And that got rid of a lot of noise, and that actually worked pretty well. After I blurred the difference, I ran through each pixel and looked at each pixel value in the difference picture, in the blurred difference picture. And whichever pixel had a value greater than 30, as in the difference between the two pixels was greater than 30, I would increase D count by 1. And D count is just the difference counter. So each pixel with the value above 30 would increase D count by 1. Right after that, I say if D count is greater than this over here, which is 0.1 times 140 times 270. 140 and 270 are the dimensions of the masked out version of the region of interest, and 0.1 is just 10%. So basically, I'm saying if 10% of the pixels of the masked version have a significant difference, then I will return true, which means like a change was detected. Otherwise, if less than 10% of the pixels had a high enough change, then I would return false. And these numbers I had to fiddle around with. Originally, I did 50%, but then that was too much, and I couldn't detect anything at all. So then I made it 0.3, then 0.2, and eventually 0.1 worked. Moving on to the main function, camera equals cv.video capture, and then stest is the name of the video of the locker, which I will show in a second. If I was using a webcam, this would be either 0 or 1, depending on if I'm using the front of the laptop or the webcam itself. Over here, I define a list. It's called vidette, or video detection. And this is where I'm going to collect all the frames that I want to compare. The next thing is f counter equals 0, and that just counts how many frames the video actually went through. S counter is how many frames I actually saved in vidette. So I'm saving all the frames that I'm comparing in this list, and that's going to be every 30 frames, which correspond to every 1 second because the camera is 30 FPS. Over here, this is just preparations to save the video. You have fork equals video read. Okay, well, this is just unimportant. It's kind of standard. This is the FPS of the video that will be saved and the dimensions of it. And then here's the passcode and the mail to actually send the video once a change was detected. We move on to the while true loop. we read each frame. We read each frame and resize it because it's just gigantic if I don't resize it. Anyways, if f counter modulus 30 equals 0 and start recording equals also 0, that means every 30th frame I'm going to grab one and then add it to that list I made earlier. And then after I have more than one frame saved, I will compare them using that function I described earlier. Process videt s counter -1, that's the previous frame, and then videt s counter would be the current frame. So the previous and the current frame. And again, the difference between these are 30 frames because I grabbed every 30th frame. Now remember that this function actually returned a Boolean. So I say if detected, just ignore this part, if detected, start recording equals 1, which basically means ignore all of this comparison stuff after I detected a change, because over here you have and start recording equals 0. So after a change was detected, I will start saving the frames and then writing them to out. Out is the name of the file where I'm saving all the frames. And then that once the video runs out, well, over here the video ran out before 10 seconds passed, so it doesn't make a difference. But if that was the case, I would count 30 times 10, which is 300. So as soon as 300 frames pass, then I would stop the entire process, like break the process. And then after that, it's just over here f counter plus equals 1, which just increases the number of frames. Each frame the computer sees goes up by 1. Not saved, sees. And then out dot release, camera dot release, and then I send the video over here, change detected dot avi, and that goes to the inbox, which would be that's not it. Be over here. So these are the ones I tried earlier, and I'll show you how it works again. So this top one is the original frame. And then on the left side of the desktop, you see the past frames being grayscaled and blurred. On the right side, you see the present frame being grayscaled and blurred. Down here at the bottom, you have the difference between this blurred image on the left and the blurred image on the right. And then the top one, or center of the desktop, you see the blurred difference. So as you see, you couldn't see anything in the difference picture until my friend walked into the frame, into the masked region of interest. And then stuff again, it was pretty let's refresh this. Come on, slow up. Oh, 0 minutes ago. Okay, here it is. Now if we download this, and then as you can see, it starts recording as soon as the change was detected. Again, the video is not long enough, but you could see that it would have continued if the video was longer. It's 0 minutes ago, so that means that was the run we just did. And that was the previous one 10 minutes ago. Okay, well, that's my algorithm, and thank you for watching. Oh, wait, some improvements. Well, if the computer ran a little faster, I think that would make all the difference in the world, because you could see it's kind of stutter as soon as my friend walked into the region of interest, and that's just because it was counting all these pixels. Well, actually, maybe if I delete this print code, it would run a little faster, but I doubt by much. But yeah, but I got a camera with better resolution and a stable mount. Those are two hardware things.